We actually talk about using the negative 180 degrees method to solve for the point over here, the intersection between the real axis and the locus. Okay, so in order to find this, so the purpose of this finding this point is actually to find the value of lambda, okay, for the face, this lambda for the gain margin, okay, that after which then you can know that whether are you stable or not. So this is what it is, okay. And therefore, the second method, okay, the first method is using the negative 180 degrees. The second method now is actually using the imaginary equals to 0 concept. Okay, so for if it's 0 in this case, the imaginary, so if the imaginary line is equals to 0, okay, so if equals to 0 or j is equals to 0, okay, so you have some complex number, right? Maybe some 4 plus 5j, or in this case 5 omega j, okay. But in this case, if this is 0, we can straight away know our real number already, right? So what this method actually do is that he took the transfer function. Okay, if you were to remember back, the transfer function is actually hold on. So the transfer function is actually this one, right? So if you were to sub in s equals to j omega, you will have this value over here, right? You have this thing over here, and this thing is actually the same thing as this, right? They are actually the same. Okay, and then now what is gonna do is actually to multiply a conjugate. Okay, is to rearrange. Okay, rearrange. So how do I rearrange? Okay, so simply is multiplying the conjugate into this function. So this is actually 1, right? So as at the very first part of the video, I did tell you that first part of the few videos. Okay, I mean, I said that please memorize the conjugate method. Okay, so now the conjugate method comes in like kind of handy. So you actually need to multiply the denominator, okay, by its conjugate. Okay, so I don't know why you don't want to multiply the numerator, but what he did was this thing. Okay, so let's just follow. Okay, so in this case, 1 plus 10 j omega times 1 minus j omega squared, as you can see, is the same thing over here, right? So j omega squared, if you were to square it, definitely you will become minus omega squared, right? Because j squared is equals to negative 1. And then this portion over here, 1 plus j squared, okay, in this case, it's a little tricky. So you can actually do out the math, and it goes into very hairy formulas. Okay, so the result shows a little discrepancy. I have 4 omega over here compared to here. But nonetheless, as you can see, this is certainly a careless mistake, so I just heck care first. But what I want you to know is that typically when you multiply a conjugate into a complex system, okay, let's say you have 1 plus j omega, right? So 1 plus j omega, if you were to multiply with a 1 minus j omega, okay, the result is that you have a 1 plus j omega square. Okay, so if you don't believe me, okay, actually 1 plus j omega square. Okay, so if you don't believe me, let's do it out. Okay, so in this case, let's say this is 1, and then minus j omega plus j omega, okay, and then minus j square omega square. So this is the result, right? So if I expand this, hopefully I can get that. So what I have is 1 plus what do I have? Sorry, my fault. Okay, let me redraw everything again. Okay, so let's say we have a 1 plus j omega multiplied by 1 minus j omega. My result should be 1 square minus j omega square. Okay, my result should be that. So if I were to do that, this is 1 times minus jw, and then j plus j omega, and then minus g square omega square. So this will be cancelled, and therefore as you can see I have 1 minus j square omega square. Okay, if I were to rearrange, I have 1 minus, because 1 square is equal to 1, so as you can see we derive this equation. So this also applies for square, even cube. So simply you can just straight away, if it's cube, right, you can just straight away put in over here cube. If it's quarter, you just put in 4 over here. So it's just simply this formula. So I just want you to remember this formula. Okay, 1 plus j omega, if you turn the conjugate itself, you have this solution. Okay, so therefore this is how he get this formula over here. 1 plus j omega square. Okay, okay, I have a little mistakes. Okay, as I shouldn't say that if it's square. Okay, if this is square, this one will be square. Okay, in this case, as you can see, if I square, this is the exact same thing in our question. As you can see, we have an outcome of 1 plus j omega square. As you can see, ours is, so shouldn't be. Okay, shouldn't be. So if it's, I will believe lah. Okay, I believe if it's square. Okay, so let me repeat the whole thing again. Okay, if it's 1 plus j omega, 1 minus j omega is equals to 1 square minus j omega square. Okay, so if the power, okay, in this, say this is the n, right? If the power is equals to odd number, this sign is negative. Okay, if it's equals to even number, the sign is positive. So if let's say this is square, it is positive. So let's say if this is 3, then this is negative. Okay, so I hope that I didn't, I believe this is the case lah. Okay, I didn't do, but I really believe. But if you can don't trust me lah. Okay, you can just look it up. If you have the answer, then you tell me. Okay, and then however, we talk so much about this thing, right? And now this thing is actually useless. Okay, why? As you can see the equation over here, what did it say? It says that 0. Okay, 0. So 0 equals to imaginary. So what thing makes this thing equals to 0? Okay, definitely this cannot be 0 ma. If this equals to 0, this, the whole, whatever thing divided by 0 will become infinity. So therefore this thing we can actually don't care. Whatever values we don't care, right? 0 divided by a, 0 divided by b, 0 divided by anything can be still 0, right? So therefore what we can say that we can evaluate this portion and solve for whatever omega values. Okay, so far I talk about omega. Okay, this omega is equal to this omega. Okay, I didn't change anything. Just this one is a capital omega, this is a small letter omega. That's all. Okay, just don't want to confuse you if you forget. And then if I were to evaluate, I open it up. I have this cap over here, and then I have 1 minus j omega square. So I will have this portion over here expanded. I'm not gonna go through that tedious part. And then I'm remultiplying again. Okay, I have a bigger portion over here. Yeah, I'm not gonna go through the math. And after which you get this value over here. Okay, and then if you were to solve again, okay, minus 10 omega cubed, right? If you were to bring this 10 over here, you are getting back what we have done earlier, right? So this will be square, so equals to 8 over 10, and then omega equals to square root 4 over 5. So which this. Okay, so I haven't finished yet. Okay, I haven't finished yet. So far the previous video we talked about deriving this 4 over 5, right? And then this video also derived 4 over 5. But we haven't solved for something yet, right? We know our frequency is this. Okay. Now what we're gonna do is because we want to know the frequency at this point, so now we already found out the frequency. But we want to know the values, right? We want to know the values from origin to, so in other words we want to find the lambda values. So in order to find that, we can actually sub it into our transfer function. Okay, our transfer function, as you remember, is this one over here, right? After we go this, and then you rearrange, and then you just sub in s equals to g omega over here, right? And then this is the magnitude, so you just sub in into the magnitude, so you can get your real value. Okay, so this is why we sub in over here. It's the same exact equation. Okay, so this equation is the same as this equation. Okay, it's the totally same equation that I'm talking about. Okay, so therefore, if I were to sub in my omega now, since I have already found out my omega is equals to square root 4 over 5, right? What I can do is actually to sub in, and then eventually you can get this value over here. It's pretty simple. I'm not going to go through this. It's straightforward. Okay, it's really seriously straightforward. But so this is the method to determine the value at this point. Okay, the real value. Okay, so next video we'll talk about how to determine the imaginary point over here. Okay, so in fact the book itself didn't go through, but I believe it might be helpful if I go through this part. So just to end the whole series for only the negative real axis, is that you have two methods. One method is using the negative 180 degrees. Another method is taking the imaginary equals to 0, and then we solve for it. In this case, right, negative 90 degrees. Okay, in this case, we can actually use if real is equals to 0, and then we can actually solve for it. I don't know, but we can see how. And then for the first method, we use the trigonometry rule. So make sure you remember the trigonometry rule. Second method, for the imaginary equals to 0, we use the complex number. This rule, make sure you go and memorize. Okay. So I will see you in the next video for this particular imaginary axis now. Okay.